Activation functions are one of the primary drivers in any deep learning network. It is the activation function that brings non-linearity in a deep learning network. And as we learned in one of the previous parts, that due to these non-linear activations, a deep learning network is capable of breaking down a complex problem into arbitrary small subproblems, solve them, and bring them together, bring the individual solutions together to find the solution to a big, large, complex problem. But there are so many choices of nonlinear functions that can be used as an activation. We have a bunch of activation function choices like tanh, ELU, ReLU, sigmoid, softmax, and so on. How to choose between these activation functions? What makes a good activation function? Of course, it depends on problem to problem, but still there is a general guideline that we should follow to determine what makes a good activation function. We have to understand how activation function and its gradient affect the deep learning model, especially the learning or training of a deep learning model. And from there, we'll get to know how to select an activation that will work the best for you. So now we are going to learn about activation and gradients. Let's go back to our drawing board and look at the neural network, standard MLP network we have been talking about. We have an X on the left side, and then we have hidden layers. The hidden layers are made up of the weight, a weight matrix, and a bias vector, W1, B1, W2, B2, and for the output layer, WO and BO, ultimately leading us to our final output, Y hat. Now, along with X, we also have the original labels Y provided to us for each sample. So, when we are learning this model, when we are training this model, we learned in one of the earlier parts that we use an approach called backpropagation. And we also learned that backpropagation uses gradient-based learning. So I just moved this to here. Let's first look at the loss function that we will have at this stage. Loss function is as simple as, I'm simplifying everything here for easy understanding. Loss is basically the actual minus my prediction, and I'm going to use a square loss function for simplicity. Now, what is Y hat? We did this exercise in one of the earlier parts, so we'll again quickly go through it. Y hat is basically derived at this layer, and what is the input to this layer? The input to this layer is the output of this layer, which is represented as Z2, and therefore Y hat is equal to Y hat is equal to dot product between its input and the weight plus the bias and an activation sigma around it. When I plug this value here, what I'm going to get is Y minus this is my loss. Now when we do backpropagation, we use a gradient based approach I mentioned earlier. And what does a gradient based approach mean? In a gradient based approach, we follow this general follow this general rule, what it means is we iteratively learn our parameter theta. So n is an iterator. So at iteration n, I'm gonna update my parameter theta by using the value I have at that iteration minus some multiplier times the gradient of the loss function with respect to theta. This is gradient of the loss function with respect to theta. So the gradient is important. Now I'm gonna derive the gradient of this loss function that I have here. Here, theta is, I'm gonna take theta as W0, so I'm gonna differentiate my loss function with respect to W0. And this is gonna be minus now to write it more shortly, this is epsilon, basically my error. You can still see that this is y and this is my y hat, but it is still y minus y hat, which is my error. So equal to y minus y hat. I can write it as here, what I want you to pay attention to is this term. Here we are taking a derivative of the activation function. So what I want you to take a note is, when we define the activation, when we choose an activation, its derivative is gonna come and play a role in our model estimation. In our backpropagation based model estimation approach, this gradient is gonna come and play an important role. And next we are going to learn about how this gradient impacts a phenomenon, causes a phenomenon that is called as vanishing and exploding gradient. And how that is caused is what we are going to learn in our next part.